All right, this video is going to cover notes from section 6.2, which deals with multiplying and dividing rational expressions. So in this first example, we're asked to simplify x plus 5 divided by x squared plus 2x minus 15. This trinomial in the denominator can be factored. We factor the x squared using x and x, and then we're going to factor this minus 15 using positive 5 and negative 3. Now we see we have x plus 5 and x plus 5 in common with the numerator, so we can cancel those terms out. And what's left over in that denominator is x minus 3. Now in the numerator, you will not put a 0 there. If the space is empty, you'll replace that space with a 1. So this is our answer, 1 divided by x minus 3. Now in the next example, we have two trinomials that we want to factor. The numerator, 6x squared plus 7x minus 5. We're going to factor this 6x squared using 3x and 2x. And then we factor the minus 5 using positive 5 and negative 1. In the denominator, 2x squared, we factor using 2x and 1x, and 5 using minus 1 and minus 5. We see the like terms, 2x minus 1 and 2x minus 1, that can cancel out. And what's left over is our answer. In the numerator, we have 3x plus 5, and in the denominator, we have x minus 5. This is our answer. Now in this next example, you see x minus y in the numerator and y minus x in the denominator. First of all, let's switch places so that we have the x and y's in the same position. So that would leave us with x minus y in the numerator, and that x term has a minus in front of it, so you're going to keep the minus in front of the x, and it's a positive y, so we'll put plus y next to that term. We have the same variables, but the signs are different. And whenever you have this situation, you can change the look of one of your expressions. It doesn't matter which one you choose. We chose the bottom expression. And what we want to do is factor negative 1 from that bottom term. When we factor negative 1 from minus x, we get positive x in parentheses. And when we factor negative 1 from positive y, we get minus y in parentheses. Now we see our x terms are both positive, our y terms are both negative, so we can cancel that out. And what's left is 1 in the numerator. Remember, you don't put a 0 there, you replace that empty space with 1, and it's divided by negative 1. 1 divided by negative 1 gives us our answer, negative 1. All right, in these next two examples, we're asked to find the reciprocal, and make a note. If you don't remember what that word reciprocal means, that just means flip the fraction. You're going to move the terms in the denominator to the numerator and the terms in the numerator to the denominator. So for this first example, our reciprocal is going to be 7 minus x divided by 2 minus x. And the second example, 3 minus x divided by negative 1. Now in this scenario, you can reduce this. Negative 1 can be divided into both of these terms. So it's essentially going to change the sign of both the terms. So it makes that 3 a minus 3 and makes this x a positive x. We just wrote it in standard form, putting our variable in front of the number. So we wrote it as x minus 3. All right, in the next example, we're asked to multiply or divide and then simplify completely. So in our numerator of the fraction on the left side, we have this trinomial, y squared minus y minus 30. This can be simplified. We can write this, we can factor this trinomial. We factor the y squared using y and y. We factor that minus 30 using minus 6 and positive 5. And in the denominator, we don't have a trinomial that we can factor, but we have a GCF. We have a common factor that we can factor from both of those terms. When we factor y squared from 9y cubed, we get 9y in parentheses. And when we factor y squared from minus 7y squared, we get minus 7 in parentheses. We bring down our multiplication symbol, and now we're going to factor the fraction on the right side. This 81y cubed minus 9y, we can factor y from both of those terms. And when we factor y from 81y cubed, we get 9. Well, actually, we get 81y squared. But what happens is this 81y squared is a perfect square number. We also factor y from minus 49y, and that leaves us with minus 49. Now this 81y squared minus 49 is a difference of perfect square numbers. You can identify your A term and your B term, and then you can factor using the sum of A and B, so A plus the B, and then the difference, A minus the B term. So our A term here, 81y squared, we're squaring 9y to get 81y squared. Our B term, 49, what are we squaring to get 49? It's 7. So we'll take our A terms, everywhere we see A, we're going to plug in 9y. So we'll have 9y plus and 9y minus. And then our B term is 7. So 9y plus 7, 9y minus 7. In the denominator, we can factor 6 from both of those terms. So 6 factored from 6y leaves y in the parentheses. And 6, when we factor 6 from 36, we get minus 6 in the denominator. So the terms that are alike in the numerators and denominators can cancel. This 9y minus 7 cancels with this 9y minus 7. The y minus 6 cancels with this y minus 6. And y, one of these y terms, if we have one y here in the numerator, it can cancel out one of the y terms in the denominator. So it still leaves one y in the denominator. In the denominator, you have that one y that's left over, and you also have this 6. So 6y is left in the denominator. In the numerator, you have y plus 5 and 9y plus 7. But this is our answer. We have y plus 5 times the factor of 9y plus 7 in the numerator. And in the denominator, you have 6y. Now, when we go from multiplying expressions to dividing fractions, I want you to remember that rule. Whenever you divide by a fraction, it's the same as multiplying by its reciprocal. So what you're going to do here is the method of keep, change, flip. That K stands for keep, that C stands for change, that F stands for flip, where we flip the fraction. So we're going to keep this first fraction the same. That 18x to the 7th power divided by 2y to the 8th power. We'll change the operation from division to multiplication, and then we're going to flip that second fraction. The numerator moves to the denominator, and the denominator moves to the numerator. So 6y squared divided by 81x cubed. From there, we want to simplify where we can. 18 divided by 2, we got 18x to the 7th power divided by 2y to the 8th power, and 6y squared. These terms can be simplified. We see that 2 goes into 18 9 times. And then that 9 can be factored into both 9 and 81. 9 goes into 9 one time, so the 9's cancel. And 9 goes into 81 9 times. So we carry down our 9. From there, we see our 6 and our 9. Both of these terms can be divided by 3. So we'll divide the 9 by 3. We'll get 3 in the denominator. We'll divide the 6 by 3. We'll get 2 in the numerator. Now, our y terms that are diagonal to each other, we have y to the 8th power in the denominator on the left and y to the second power. We can divide out those 2's, right? So we could factor y to the second power from both of these. Take away 2 of the y terms from the 8, and that leaves us with y to the 6th power in the denominator. So our 2 terms that are left in the denominator are 3 and y to the 6th. In the numerator, we had x to the 7th power. We have in the denominator over here x to the 3rd power. So we can cancel out 3 of those x terms. If we take 3 of those x terms from this numerator, we're left with 4. So in our numerator, we have x to the 4th power times the 2. Remember, we had 2 left over after we factored 2 into both of these terms, the 6 and the 9, or 3 into both of those terms. Our final answer, we had 2 times x to the 4th power in the numerator divided by 3y to the 6th power. So we're keeping the first fraction the same, b squared minus 9. This is a difference of perfect squares, so we just factored that numerator as b plus 3 and b minus 3, our a and b term. The denominator stayed the same, b plus 5. From there, we change our operation from division to multiplication. And then we flip the second fraction. So that b moves to the numerator, and in the denominator we have 3 minus b, but we reordered this to write in standard form. We reordered it as minus b plus 3, put our variable in front of the constant, and then we factored out -1 from both of those terms. When we factor -1 from minus b, we get positive b. When we factor -1 from positive 3, we get -3. So in our denominator, we have -1 factored out and b minus 3. We want to change that format because that allows us to cancel the b minus 3's. We also see what's left in our numerator as a part of our solution. We have b times b plus 3 in the numerator. And in the denominator, we have this -1 times b plus 5. So we just carry the negative out here. It applies to the entire fraction, and then carry down the b plus 5. This is our answer, negative b times b plus 3 divided by b plus 5. All right, we're going to keep change flip again. In our numerator, we have x plus 5 of our first fraction that will stay the same. X plus 5 in the numerator, and in the denominator we have x cubed minus x. We can factor x from both of these terms. When we factor x from x cubed, we get x squared in parentheses minus, when we factor x from x, we get 1. So this x squared minus 1, we factor, because this is a difference of perfect square numbers, we can find our a and b terms, and we'll factor using that format of a plus b and a minus b. Our a term, what are we squaring to get x squared is x, and our b term, we're squaring 1. So we have x plus 1 and x minus 1. From there, we change our operation from division to multiplication, and then we're flipping the second fraction. We flipped our second fraction so that x to the 4th power moved to the numerator, and x squared minus 25, that's a difference of perfect squares again. You can identify your a and your b terms. A term, we're squaring x to get x squared. Our b term, we're squaring 5 to get 25. So x plus 5 and x minus 5. We'll cancel x plus 5's. We'll also cancel one of these x's. So see, we have one x outside parentheses in the denominator. We can cancel that with one of the x terms here. So take away the 1 that we're factoring out. We're left with x to the 3rd power in the numerator. In the denominator, we have x plus 1 times x minus 1 and x minus 5. This is our answer. All right, that'll be the last example for this section. We'll stop here.